Welcome to section 4. This is going to be broken up into two videos, one dealing with addition and the other dealing with multiplication. Okay? Had to get the pen working. Addition, the main thing to remember is, I just said it, I must speak and type at the same time. We only add, subtract like radicals, and just like polynomials, meaning if I have a 5x squared plus 2x minus 3x squared, we know that we can put these two together and call it 5 minus 3 is 2x squared, but it won't combine with the 2x. That's a lesson that we've learned, and that's a thing. It's the same story with radicals. Watch this. So looking at this example over here on the left, someone says, simplify the following, and look at this expression. There's a radical 7, radical 2, radical 2, radical 7. You treat the radical 7s like radicals, and typically when you get super good at this, you don't do what I'm about to do, but it makes it easier to see. I'm showing you, I'm going to put those two together. Okay, I know there's other stuff, but when I put those two together, and I'm anticipating, the thing is about combining like terms, remember, is we're always, the background to it, or the reason it's true, is it's the distributive property. Each of them have a radical 7, factor it out, look what I've got. I've really got 13 square roots of 7. But you don't have to do that. Basically, if you're super on this, you go, well, those two go together, and you might do these lines in a different color. And maybe you pick green or something if you got a good markers, and you go, these two will go together, right? If you're super quick, okay, 3 and 10 make 13 radical 7. So I'm not trying to slow you down. In the other case, you've got minus 2 radical 2 and then plus radical 2. And that's like saying minus 2x plus x, which is tricky at first, but then you realize it's just minus x, right? That's what's happening. So in this case too, you can, if you want, factor out the radical 2, but I think what I'll do is I'll just write it as minus 2 radical 2 plus 1 radical 2 so you can see it, and finally maybe write minus radical 2, 1 radical 2, or just radical 2 as an answer. So we're just combining the like radicals. They have to have the same square root or cube root or whatever in order to say, yes, I can add these together. Otherwise, just leave it alone, all right? But, here's another one. We've got the cube root. Watch this one. We've got 5. Look what I'm looking right there. It's the cube root of 12x. Even though it's messy, over here, it's the same animal, isn't it? So, can you get your eyes trained on that one? You don't get lost on the symbology. You simply go, those are the same. In fact, if I think I'm going to factor that out, not that you have to, I'm just doing that so you can see it better. Look at that. If you see it right away and skip that step, fantastic, you can do that. But in this case, we have minus 6 cube root of 12x. That's it. So that's what we're in the midst of, is the arithmetic of radicals. The previous one was about simplifying. The previous video was about simplifying, which is all important. Coming up next, you'll see why. But we're starting this whole thing about adding, subtracting, multiplying, and finally dividing in the next section, dividing radicals. Okay, so how do we do that? Here you go. Now, here's the thing. What makes this exciting or fun or whatever is that at first blush, you look at a problem like this one, and look what I'm writing. Of course, there's always a chance that one or more radicals need to be simplified first, which is true. Okay, so radical 20 and radical 45, they can't combine. They're unlike. But they're also not simplified. And you always, 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 always simplify your radicals. Okay, that's what you do. So in this case, well, let's see what we got. We've got to take 20 and go, well, 20 I know is 4. If you know 20 like I know 20 is 4 times 5. Every time I see it now, of course, I'm a math teacher, but if you need to split it up, you'll figure that out. So in the previous section, we learned I can square root the 4. to get a 2 radical 5. So instead of looking at it as a radical 20 or square root of 20, look at it as 2 square roots of 5. Okay, let's go to the next one. 45, isn't that 5 times 9? And isn't 9 a perfect square? It is. So we go plus square root 9 times 5, but we can square root the 9 and say 3 square roots of 5. And the problem that said, add the square root of 20 to the square root of 45 can be rewritten as add 2 square roots of 5s to 3 square roots of 5. What do you get? Well, I get 5 square roots of 5. That's what I get, and that's the answer. So you got to simplify first. Here's another one. It's a little bit more interesting. I'll let you pause and try it yourself. Okay? Don't just wait for me. Do it. Okay, that's an interactive thing. Okay, so let's do this one. Let's see. It's kind of complicated. Each one has got his own little challenge. It's kind of crowded too, the way it's typed, but I'll do it. Inside 50, you might go to the side sometimes, 50. I know you're thinking 5 times 10, but we're looking for a perfect square. So inside 10 we know is 2 times 5. There it is. It's 5 times 5. And, oh, it's 25 times 2. Good. Okay, so we have 3 square root. I didn't say this, but I should have. Each one we've done so far is just dealing with square roots. Well, maybe not the one above. But so I should have looked at that. But yeah, we're looking at two of a kind. So we've got, we know our square roots. So sometimes I just write 25 times 2. But then, well, what else? A squared. Okay. If you want to continue the story on just this one guy, and sometimes people do that. They go, let me just work on one until I get it done. You don't have to do that, but I'm going to do it. So I'm going to say I can square root 25. So watch this. 3 times, what do you get? 5 times, square root a squared, a, and who's left over? 2. Square root of 2. So what we have is we're looking at 15 times a times the square root of 2. Hoo-ay. Okay, that happened. Let's go to the other two. Now, 8 is going to become very, I think, kind of simple for you. It's just basically 2 times 4. So I'll bring it down here and go, I've got 2 square root of 4 times 2, but I square root the 4, right? So I have plus 2 times 2. Actually, I could have put it right here. So let me go plus 2 square root 4 times 2, and then you square root that guy. And I'll put this step up here because I'm weird. Times 2 square root of 2. So we're really looking at 4 square root of 2. I can't wait to do 98, right? So 98 is, man, what the heck? Use your calculator on it. It's even, so if you divide by 2, you get a, 49. That number's familiar, isn't it? That's really plus the square root of 49 times 2, but the square root of 49 is 7 square root of 2, so that's what we drop down here, 7 square root of 2. Can you read all that stuff? Pretty busy problem. Boy, it'll strengthen your brain by doing these things. Now, you get them simplified. What can we combine, if anything? Can we combine all 3 of them? These two are the same. They're radical 2s. But that's a radical 2, but what's different? Yeah, it's got that a. If it's got that other thing, when you factor out square root of 2, it's still going to be 15a. In fact, if you do that, it's probably a bad idea to do it. You should realize that since it's got the a, it's unlike. Okay, but these two can certainly be combined. So this is really saying I've got 15 of these a times radical 2 things, but then I've also got 4 square roots of 2 plus 7 square roots of 2. When you say it in English, you go, well, that must mean I've got 11 square roots of 2. You know what people tend to do sometimes is when they add square roots together, you know how when you were a beginning algebra student, you go 3x plus 5x is 8x squared. And we go, no, it's not. It's just 8x. Well, people tend to do that here too. 3 square root of 2 plus 5 square root of 2 is 8 square root of 4. No, it's not. Don't do that. It's just 8 square root of 2. Okay? So these are growing pains. All right, that's adding. Let's see if I have anything more. Nope, multiplication's next. So that's the end of this video. Get ready for the next one.